So hello, everyone. My name is Rick Spurgeon. I'm a developer advocate here at Kong. Here are some ways you can reach me if you'd like to connect or discuss today's topic. You can find me here on LinkedIn or my GitHub profile below. So today's topic is building dynamic APIs with GraphQL. And so what do I mean by dynamic? For me, thinking about APIs as products, which is something we do here at Kong, dynamic is about unblocking our API consumers who have very complex and diverse needs without rewriting the world for our API producers. We'll dive in more in what I mean here in a second. But first, I just wanted to give a quick agenda of what I'm going to cover. First, I'm going to recap that problem and discuss it a little bit more in detail. We'll do a quick run through of some base GraphQL concepts, kind of a GraphQL 101. Then we'll look at some code that I've written for a GraphQL service using the Apollo SDK. This interacts with a set of REST APIs for a fictitious airline that we call Kong Air. And then finally, we'll explore some client requests for the GraphQL service using a few different tools, some command line tools and some UI tools. So let's get started. So what's the challenge that we see? So web, mobile, and other client teams are tasked with building applications that display kind of a diverse set of views, and they adapt to the changing product needs. So you can think about application design patterns like model view controller or model view model. Take, for example, our airline. This might include customer information screens that bring together profile information, and maybe it merges together a customer's flight bookings. And, the application has to merge this information into a customized view for a user. We think of these applications as experience applications. This is what the user sees and uses. So on the back end, APIs are often organized into domain teams following domain-driven development. And more, these teams are organizing into these domains and serving their APIs as products. These APIs are often RESTful by design, typically dictate the data model that is available to the clients. And this is great, but it does create some challenges for the client app developers. The app teams usually need access to data across multiple domains, multiple domain APIs, requires them to, invoke multiple requests and then stitch together the results. Imagine building a client application that must retrieve the customer's booked flight from the booking service, but then the flight data is in a flights API and they have to stitch these things together. Again, this requires multiple API calls. They must have keys and IDs matched up. And then on the client side code, actually stitch the data back together and present it to the user. Now you can imagine doing that for many, many microservices. And you can start to imagine the difficulty and how this problem grows. Development organizations responded to this by building customized services to serve these experience APIs. This is akin to building the model or the view model into a backend service specialized to a particular view for the front end. And this is often referred to as the backend for front end API or BFF. But really, this is an anti-pattern. BFF APIs tend to sprawl as the applications grow or the applications view multiply, and they become a maintenance burden as the clients and the domain services evolve. This middle layer becomes quite cumbersome. So GraphQL offers a solution, and let's look at some base concepts first. So with GraphQL, the services adhere to a type system. This type system describes the objects and the relationships between them. And when you implement a GraphQL service, you define a complex type in the fields that define them. You define the relationships between them, just like a graph, just like it's in the name and in the logo here. And when you go to implement a GraphQL service, you build out functions for each of these objects and fields to compose up the type. GraphQL schemas are native to the protocol. This supports things like introspection, allowing clients to find out what a service can support. But however, in my opinion, the key difference from traditional API design is how we invert control between clients and servers in the GraphQL model. So clients can shape the queries dynamically, while the data providers in the backend can stay relatively static. So what I mean, clients can request only the data they want and are sent back only the specific bits they need. So this improves the client-side performance, and it creates a dynamic interface for them to flexibly evolve, and which is also true on the back end. This key abstraction layer can allow the front end and back end to evolve independently. And at a GraphQL service layer, we can pretty seamlessly integrate multiple backend domain APIs together, and it's very seamless for the client. Continuing GraphQL kind of 101. Additionally, GraphQL supports things like client-side filters. So clients can further narrow down the information they need, say particular flights or particular routes or particular bookings. And this is a way for them to further narrow down the data that they have to process. GraphQL also supports data mutations, which is the right side of the equation for the backend service. We're not going to cover mutations here today, but there's a lot of other features that I'm not going to cover. This is kind of a 101 look. So you can find a great resource in the GraphQL Learn site. It has a lot of great information. So let's look at some code, and we'll start with what a schema is. It's so important to a GraphQL service. So at the top left, you see there's a query definition. All GraphQL schemas must include one query. You can think of this as the entry point into your service or API. For our airlines API, I designed it from the perspective of a user looking to obtain information from their account. That's why it says me. So you can imagine the client application invoking a request based on the perspective of the calling user. The me API allows the client to obtain information for a specific logged in user. And in our case, we're going to use JOT tokens, Java Web Tokens pass-through requests to authenticate and identify users. But from that me query, a client can request any number of data items from their account, from personal information like their name, username, frequent flyer number, things like that, into, let's say, their bookings, the flights that they have booked. And when you dig into here, you can see a booking has a ticket number and a flight. A flight has information like the flight number, or routing information like the origin and the destination, the duration of the flight, the route ID, scheduled departure and arrival times. And the booking also has things like the ticket number and the seat. So what's interesting about this is a client can request any or all of this information depending on their particular needs for their particular view. This is the key difference to me in GraphQL, is this dynamic nature of the request can pull from only the relevant bits of this graph that the client needs. In a traditional REST API, this data model would be much more fixed, and the client would be stuck parsing and filtering out the information on the client side that they need. So let's get into some real world example here. I've built a working example called Kong Air. You can find this on GitHub here. The repository contains functioning domain REST APIs, including some hosted versions at an address api.kong-air.com. I've built an easy to run GraphQL service, which is configured to load the data from these hosted domain APIs. So this allows us to quickly, which we'll do today, boot up a GraphQL service and explore it. You can see an example of a Kong Air REST API call above. This is an example of one of those domain APIs that we're going to stitch together into the GraphQL service. I'm going to quickly flip over to the Kong Air repository just so you can kind of see what's here. There's also a bunch of automated systems in here, and this is a functioning application using Kong Connect, Kong's SaaS platform for API management. There's some interesting things in here that I covered in a different talk on API ops. But essentially in here, there's some REST APIs that we've built using Golang, but also Node.js. And these are what drives that hosted version. So you can run these APIs locally as well if you want to follow along on the instructions. But here in the experience folder is where we're going to focus, and this is where the GraphQL layer for our system lives. So let's talk about the important building blocks of the GraphQL service. So in a schema.js file is the previously shown GraphQL service schema definition. There's a folder in here called data sources that has classes that fetch data from the REST APIs, those upstream domain REST APIs. And this uses the Apollo SDK to assist with things like caching and request deduplication, error handling. We'll look at that a little bit. Resolvers.js is something I'm going to talk about in a lot more detail, but this file contains the key functions that populate the data for the GraphQL queries. And finally, there's an index.js file, which contains the code that assembles all the components together, runs the service, and basically bootstraps this all together. So let's go ahead and actually look at the code and look at some details. So I'm going to flip over to my code editor. And the first thing I'm going to do is let's look at the schema in some detail. So this is that schema repeated here again. But this schema here, using the Apollo SDK, is defined inside of a JavaScript template literal. This schema string is then parsed and into a GraphQL syntax tree at runtime. So here you can see this is a JavaScript file and type, but we use this literal here to allow us to type in the schema using GraphQL query language inside of a JavaScript file itself. Here we've repeated all of these things, the me type, the me query, the booking type, and then down into the details of each field. A couple things I want to highlight here. So we have names and types, but also at the end we have this exclamation point. So this exclamation point defines non-nullability for a particular field. In this case, we're saying for the GraphQL client, if you receive an instance of this me object, the name field is guaranteed to be non-null and of type string. So for anyone who's done any programming, especially in dynamic languages, this can be quite helpful. But it's true in all languages, I guess. But here, this can be quite helpful for the client application developer. You'll also notice this array syntax here around the booking. And what this means is the bookings field inside of the me object is an array of these booking objects. We can apply non-nullability to these as well. And so what this line says is the bookings field is a collection of booking objects. The collection itself is guaranteed to be non-null, and any object instance contained within it is also guaranteed to be non-null. Of course, the bookings could be an array, an empty collection, but if you get a value, the client can lean on the fact that this non-nullability documents and requires in the SDK that they're valid instances. If we just kind of scroll through here, you can kind of see the layout. The me object contains personal information. So if we go down and look at what my info is, we have an address, a phone number, an email, frequent flyer, payment methods. A payment method has a card number, name, expiration date, etc. Going back up, if you look at bookings, the booking object contains a flight. You know, the booking and the flight are separate domains actually on the back end. You know, thinking about a relationship in a traditional database, there could be one flight related to multiple bookings. So a flight has a number, a route, scheduled departure and arrival, and then flight details. Flight details might contain aircraft number, et cetera, et cetera. So you can see we've built here an object model in this GraphQL language. And this empowers our user to request any individual, specific bits within this schema that they need. So how do we stitch this together with our backend service? So let's look at these things called data sources. So if I look at the data source here for our flights API, so this is a code block that connects GraphQL service up to that domain API. What you'll see here is we have an extension of an SDK, an Apollo SDK provided object that provides some base services for us. Again, I think I mentioned it earlier, caching, error handling, etc. And these functions match what our upstream REST API provide. If we actually go up to, we can go look inside of our Kong Air flight service, and we look at this open API spec that defines our flight service, we'll find matching open API spec routing documentation that matches that. So there's a flights route, there's a flights route with a flight number, and there's a flights detail that takes a flight number. And so inside this open API spec, you can see these three different routes. So if we go back and we look back at our flights data source, you can see these functions match those three routes. I want to look at one more data source, which is the bookings API. There's one thing here I want to also highlight. When this bookings API is constructed, it takes a few more bits of information, an options object and a request object. This is contextual information for a request, and we store this information critically to pass it along to the upstream request. So here you can see for the request we get, we take the authorization header, we store it so that when we call up to the booking service, we can pass through this authorization header. That allows us to just kind of seamlessly pass through, and we don't have to do a lot of code. This is just not much code to like pass the kind of delegate the authentication up to that upstream domain service. I'll show how this is stitched together in a few minutes. Now, the most important file probably, I mean, they're all important, but you know, a key file here are resolvers. And so this is an interesting file. Resolvers are what map the schema to the functions that populate the data for the objects in the schema. So what you'll notice here when you look at this is it matches the schema in its parent-child relationship, but also in these fields. You'll notice there isn't a field for every value that we've defined in our schema, but critically only the ones that we want to call out to these external data sources, these upstream domain APIs. There must be at least one resolver for any matching schema. So we would, you know, clearly you'd put one onto the query. This is the entry point for the query that a client will make. This is that me query, and it matches our upstream customer information API. So here we're using our data source, and we're calling that customer API data source, and we're calling the get customer function or route to populate the data in the me query. And you'll see here, we also have defined that me object. So this is a mixture of types and the fields contained within them. On the me object, we had a bookings type. If we go back and look at the schema real quick, you see this bookings field matches what's in that resolver. There's a me type with a bookings field. In our case, the way that our company's data model is defined, bookings come from the bookings API, not from the customer API. So we have to delegate this particular field's data request up to the bookings API. You can kind of start to see how setting a particular field for a particular object can be done, you know, on a per field basis. But we're missing a lot of fields. Why is that? So for example, in the me object, there's a username, but we don't have a username here. Why is that? Well, it's because our customer API is populating that me object type from this me request. And it just so happens that the customer API data model from the upstream REST API returns a value that matches the me schema perfectly in name and type. And when that happens, the Apollo SDK can automatically default and populate that value for us. So we don't have to provide that. This allows us to write this resolver pretty trivially and include only the things that we need to get from these different and like disparate upstream REST APIs to populate the data. Here's an example where you can kind of see where we're using the parent object, which in this case is a flight object inside of this field. We're getting the flight number to then call that get flight details route that I showed you earlier to populate the details of the route. Again, I've modeled our GraphQL schema to match the upstream REST API data models perfectly so that GraphQL can really help me and populate almost all of this data for me. I've only had to write specialized functions for the for the fields that delegate the work to different upstream domain APIs. So I hope that makes sense. It's a little difficult to explain, but if you go look at the Apollo SDK documentation for resolvers, I think it might give you a better explanation. Okay, so finally, let's look at the index file, the index.js file, and this is where it all gets put together. All the components are brought in, the Apollo SDK, our schemas brought in, our resolvers are brought in, all of our data sources are brought in, and we build and configure and build the Apollo server. There's a lot more documentation on this as well. I encourage you to read. But critically, there's this key function here. This is a contextual function that we pass into the start standalone server. What we're doing here is we're telling the server, for every request, I want you to run this contextual function. And within here, we provide, we create new instances of our data sources for every request that's invoked. But we also pass some key things in, including the request itself. So you see here, if we went back to our bookings API, you'll remember in the constructor, we passed in a request. Here we're doing that. We've taken the request, from this function provided by the server, passed it in the bookings API. And again, that was so the bookings API could store it and then use it as a header in its upstream request. Go back. Okay, so if I go back to index, and then so this function is ran again for every request, and that allows us to handle the authorization scheme that we want to implement. And so here we just print out some information about the running server and we start the server. That's a quick overview of the code. I want to actually run it now. So what I'm going to do is I'm going to go over to a terminal, and we can just run this directly using Node. And you can see we have a server now running at localhost 4000. Okay, great. So let's show how we can query this from the client's perspective and be dynamic in what we get back. But before we do that, we have to once again talk about those authentication tokens. So I've provided some authentication tokens. These are the Java Web Tokens, and you can just source those in. It will set up some environment variables for you to use them. What this allows us to do is to then pass them through to our GraphQL service. So here's a query. We're using curl, specifying what kind of data we can expect and what kind we will pass. Here's my colleague, Danny. She's got an account with Congair. And in that previous source command, I brought in a bearer token for her that I stored in this variable. And I can then pass that through to the query. And here is the queries itself. We're telling GraphQL we're going to run a query. It's the me query. And here's all the fields we want. And you'll notice that these are field definitions from the schema. We want to see our username, our bookings. And from our bookings, we want to see a ticket number, a seat, a flight. And from the flights, we want the flight number, the route. And from the routes, we want the origin and destination. So here's the graph. This is the graph we're requesting. And we can actually ask it directly for just this bits of information. You might notice that we're hosting a request using curl here, which is somewhat interesting for a read operation like a query. But GraphQL kind of idiomatically expects a very complex JSON object as the query. And since HTTP doesn't typically expect a body in a GET request, we use posts. Most GraphQL services, as I understand it, can accept a query parameter on the URL, but I think this is more commonplace. So let's go ahead and run this and see what we get back. We get back this nice clean data structure with just the fields we've requested for Danny's bookings. So what's interesting about this, right? Well, what's interesting to me is, let's say that we have a different view we need to write, and we don't need the route information. We don't need origin. We don't need destination. We just don't need route. We can run the same query, except we've removed the routing information from the query string. And if we run this, you can see that the routing information is not provided. Clients can query anything across this schema that they need without changing anything in the GraphQL service, without changing anything in the domain APIs, and it provides a lot of flexibility. There's one more thing I want to show you here as I'm running short on time. If we open a website that is served from the local machine, is served from the local Apollo server, This is an interactive UI that you can use to query your GraphQL service. This is provided by Apollo. It's called the Sandbox. The first thing you want to do when using Kong Air is also set those authorization tokens. So if you go into these connection settings and you set that value in here and save it, what will happen now is as we invoke queries out to that service, our header will be contain a valid authorization token. This has lots of things. It can introspect the schema. You can evaluate the schema, look at documentation. But today I just want to look at this query runner. And you can see here we have queries that, from the root of the schema, we have queries. We can go into the query and see our me. We can see our me query. What I can do now is just click and add things to this and start to see information about my particular thing. Because we've passed that auth token through, it contextualizes for me, the user, in this case, Danny. I can add flight details, the flight number, the aircraft type, like meal options. Let's say I want all of the routing information. There's a helper button there that I keep forgetting about. I want the flight number. And let's say I also want a little bit of my information, like my frequent flyer number. So just pointing and clicking here, I've created a custom query. Again, very dynamic from the client's perspective. And I get back just what I need to build my view. So that is provided in like development versions of the Apollo server for, a very easy user interface style evaluation tool of your GraphQL service. So I hope this helps show what I meant by dynamic and what GraphQL can provide. Sorry, back here. That's basically all I wanted to cover today. I provided some helpful links here. Here's the link to Kong Air again. I've written a blog post series on GraphQL, which you can find here. That's on the Kong blog site. The Apollo documentation is great. You can get lots of information from that. And again, you can find me on LinkedIn at this location. And I hope it was helpful, especially those that are new to GraphQL. And if you'd like to reach out and talk to me about any of this, please feel free to connect. And thanks for attending API Summit.